In this video, we're going to learn about two new terms in 8th grade math. One is rational number and the other is an irrational number. Every number falls into either the rational number category or the irrational number category. And the very big idea between the two is that rational numbers can be rewritten as a fraction, while irrational numbers cannot be rewritten as a fraction. Okay, so if you can rewrite a number as a fraction, it is rational. If you can't rewrite it as a fraction, it's irrational. So let's look at some examples here. The number 5. You could write that as 5 over 1, which is a fraction. That makes this rational. Same thing with 0.25. That's 25 hundredths. So 25 over 100 also reduces to 1/4. Okay, no matter what fraction you make it into, if it can turn into at least one type of fraction, you've got a rational number. Square root of 64. That can be rewritten as the number 8, and 8 can be rewritten as 8 over 1. So since it can become a fraction, it is rational. And then 0.3 repeating. This is a decimal that repeats, and any repeating decimal can be turned into a fraction. 0.3 repeating we know is 3 over 9, which reduces to 1/3. As long as you can make one fraction out of it, you're good to go. Now on the opposite side are our irrational numbers. So what do those look like? We've got our decimals here. Okay, this ... tells me this continues, okay? And you'll notice that the part of the number that we can see, there's no repeating numbers here. If there were repeating numbers, then we could say, oh, I know that repeating numbers can be turned into fractions. But since there's no repeat going on here, this cannot be turned into a fraction. And it's also non-terminating, meaning it doesn't end. So if you can't get a decimal to repeat and you can't get it to end, that makes it irrational. You will not be able to find a fraction that matches this number. Same thing here. We've got a whole number in front, 135 point, and then 28309823 ... The ... tells us it keeps going. It's non-terminating. And because we have no repeating numbers, we're going to assume that it doesn't repeat at any point. Okay, now technically, could this number repeat after the ... Yes, it could. But in math and when we're practicing these, you're going to assume that if you don't see it happening, it's not going to happen. Okay, nobody's going to try and trick you and say, haha, later on this repeats and you had no idea. You wouldn't know that, therefore you can say this is an irrational number. Square root of 2. Now you'll notice that a square root like 64 ended up being rational. But a square root like 2 is actually irrational. And that's because any square root that does not have a perfect square inside is a never-ending, non-repeating decimal. Okay, it's like the number pi. It keeps going forever and ever. There's no repeats. Every single square root that's not a perfect square is like that and will be an irrational number. So just to remind you what other square roots there would be, like square root of 3, square root of 5, square root of 6, square root of 7, square root of 8. Square root of 9, though, would be over on this side, right? Square root of 10, square root of 11, square root of 12. Square root of 16 would be on this side, though. So the perfect squares are rational, while the non-perfect squares are irrational. So square root of 50. That's going to be irrational because it's not a perfect square. It's a little bit past 7 because the square root of 49 is exactly 7, and it would be a rational number. But the square root of 50 is 7 point something. That would make it irrational. Okay, so a couple of notes here. Rational numbers can be non-terminating as long as they are also repeating. Okay, so 0.3 repeating, 0.6 repeating. If you see it as a decimal, it would be like this, where you can clearly see there is a repeat pattern going on. Okay, 8585 ... Again, this kind of cuts off before you really see too much of the numbers. So you can assume that what you see is what's going to keep happening. Okay, 8585 ... You can assume that that is the equivalent of 0.85 repeating. Okay, and then all square roots of perfect squares are also rational. All right, remember all your perfect squares, 1, 4, 9, 16, 25, and so on. And then of note over here, all square roots of non-perfect squares are irrational numbers. Okay, so 2 things you're looking for. Well, 3 things really. 1, if you can turn it into a fraction, it's automatically rational. Okay, if it's already a fraction, it's rational. If it's not a fraction, but it's a decimal that terminates, it will be rational because you can turn it into a fraction. If it's a decimal that repeats, it's rational. The ones over here, where it's a decimal that does not repeat and does not terminate, those are the irrational ones. Okay, so if you see ... that could mean that it's going to be irrational. You got to look for the repeats. And if you see a repeat, that would actually put it on the rational side. Okay, so watch out for repeating numbers. And then your square roots of non-perfect squares are your irrational numbers as well. Okay, something that you do want to watch out for is irrational numbers that go like this. A lot of people will look at this and say, oh, that's a repeating number, but it's not. If it was repeating, it would be 1, 2, 1, 2, 1, 2, 1, 2, and you can see it's not. There's a pattern, but it's not a repeating pattern. This goes 1, 2, 1, 2, 2, 1, 2, 2, 2, and so on and so on. This would be irrational. That's not a repeating pattern. That is just a regular pattern. It's not repeating though, therefore it's going to be irrational. So we're going to practice here identifying some of these, okay? Square root of 2, this square root right here is probably the biggest irrational number you will want to know. Square root of 2 is irrational. In 8th grade, they make a big deal out of knowing that the square root of 2 is an irrational number. So you know, since it's a non-perfect square, square root of 2 must be irrational. It's going to go on forever and ever and ever. If we actually check that on the calculator, okay, square root of 2, you'll see it goes on and on and on. My calculator stops it at this point, but it does keep going forever and ever. And unfortunately with calculators, they don't put a ... at the end, or most of them don't anyway. So you kind of have to assume that if it just stops right there, it doesn't actually terminate. It's just that your calculator won't show you any more past that. Okay, so keep that in mind when you're looking at your calculator. Square root of 7 is the same type. It's a non-perfect square, so that makes it irrational. You cannot turn it into a fraction. Square root of 25, though, is just 5. And 5 can turn into 5 over 1. That makes it rational. The cube root of 27, that's 3. That's a perfect cube is what we call that. That would be rational. Okay, so a decimal. If it stops, it's rational. It doesn't stop. It's got the ... The other way is if it's a repeating number, it's rational. This is repeating, 6, 3, 6, 3, 6, 3. That's a repeating decimal, which makes it rational. I can turn this back into a fraction. Okay, this guy right here, it's a decimal. It doesn't repeat, or it doesn't end, so it's non-terminating. And looking at this, I don't see this repeating. 1, 4, 5, 6, 3, 1, 2, 6, 4. That's just nonsense numbers. There's no repeat. It doesn't end. It must be irrational then. Okay, so if it doesn't repeat and it doesn't terminate, it makes it irrational. The number pi is another very famous irrational number. Okay, you guys remember from 6th grade, when you first looked into pi, it goes on and on and on and on forever and ever and ever. That's an irrational number. 6.17, this one ends. I can turn this back into a fraction, right? 6 whole numbers and then 17 out of 100. That's a rational number. 1/9. It's already a fraction. It must be rational if it's already a fraction, but some people get caught up thinking, ooh, I know that's going to be a repeating decimal. What does that mean? Well, it doesn't matter. If it's a fraction, it's automatically rational. So don't get hung up thinking, ooh, is that repeating or is it terminating? It doesn't matter. If it's a fraction, it's automatically rational. Same thing with 2/7. You're thinking, ooh, I know that that's a repeating decimal. Nope, it's just going to be rational. All right, this guy right here, I get a lot of incorrect answers on something like this. People will say irrational when in fact it's actually rational because there's no ... here at the end. ... tells me it keeps going. If there's no ... it ends right here. That's a terminating decimal. So even though it's not showing any repeat numbers, it still terminates, which means I can turn that into a fraction. I would have to figure out what place value this is. That's going to be a really long number for the numerator and the denominator, but it will still become a fraction. Okay, square root of 225. Is it a perfect square or non-perfect square? That's the trick. This is a perfect square. It ends up being 15. 15 is 15 over 1 is a fraction, so this makes it rational. Sometimes you're going to get tricked by things like this. the square root of 3 times the square root of 3. The square root of 3 by itself is irrational. What happens if you multiply it by itself? Let's actually look on a calculator and see what happens there. The square root of 3 times the square root of 3. Interesting. Now the question is, did I put that into my calculator correctly? I don't think I did. The square root of 3, let me end the parentheses this time, times the square root of 3. Let's end the parentheses this time. The thing with calculators is that you have to be really careful about how you input things, because you might think that you inputted them correctly, and then you find out, wait a second, I don't think that actually works out the way it's supposed to. So do you see how I actually had to end the parentheses here in order for it to correctly multiply the square root of 3 times the square root of 3? It's very tricky. Now, because I knew that it was supposed to end up being just the number 3, that tipped me off that I did it wrong the first time. So please just be careful when you're trying to use the calculator to do your multiplication for you. You got to make sure you're doing things correctly. So the square root of 3 times the square root of 3, any square root times itself just gets you the number that's inside. So square root of 3 times square root of 3 will be 3. If I tried the square root of 5 times the square root of 5, it would be 5. Square root of 99 times the square root of 99 would be 99, okay? So because that happens and that the square root of 3 times the square root of 3 just ends up being the number 3, that's a rational number. Okay, so watch out for things like that. By itself, it's an irrational number, but when you multiply it by itself, it ends up being rational in the end. This is read as 5 times the square root of 2 because they're squished up together. That means multiplication. 5 times the square root of 2. If you have a number times an irrational number, it's going to stay irrational. So even though this is a rational number times an irrational number, the irrational number is going to win. 876 over 17, a lot of people will panic at this point because it's such a big fraction, they don't know what to do with it. And you just got to remember, you're just being asked, is this rational or irrational? If it's already a fraction, it's rational. There's nothing else you have to do about it. And then the last number here, okay, there's a dot, 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 so I know it goes on forever and ever. So the question is it repeating or not? Because if it repeats, it's rational. If it doesn't repeat, it's irrational. If you just look at the first few digits, it looks like it's not repeating, but then it gets into a repeat pattern, 5, 4, 5, 4, 5, 4. This one ends up repeating, so it is rational. I could make this into a fraction. It would be a big pain to do it, but I could do that because it's a repeating decimal. And that's it. That is our rational numbers versus our irrational numbers. Big idea, again, remember, is that if you can turn a number back into a fraction, it's rational. If you cannot, which would basically be your decimals that never end and don't repeat, and your square roots that are not perfect square roots, then that makes it irrational.